Hello everyone and welcome back to another Universe Sandbox video, and today we're going to be continuing on with evolving our 7th custom solar system from birth to death. So, if you remember last episode, we had a pretty crazy wild one. We picked up a second star from interstellar space. There was a rogue object that we captured in this system, and that has really messed up our orbits. As you can see, everything is in absolute turmoil. Our primary star, obviously Procon Hill, this is now a red giant, and it's on its way to becoming a red supergiant. So things aren't going well, as you can see. I mean, this star, it could get ejected eventually. I don't know. It could pick up a little bit closer to the star. Maybe it won't. We'll have to wait and see how this really folds out, to be honest. So without further ado, let's continue with evolving our system. So as you can see, the orbits are just nothing's consistent anymore. I mean, remember, this system originally started with all the objects being spherical, but now they're pretty much every single one is an oval. You can see there's constant interruptions with the orbits. Nothing is staying the same here. I mean, look at some of these. I mean, what has happened here? Oh man, so that's pretty crazy. I don't think there's any planets with lifelike conditions left. I think everything's either been ruined, burnt out, or it's just lost its position. So yeah, not good. Yeah, all the planets that were nice have already been destroyed, pretty much. Already lost all of their conditions being too close to the star, and obviously all the ones that were further out that could have had lifelike conditions have their orbits have been ruined, so they can't really get in a consistent orbit. So not good. How's this really? This planet is so cool. Such a weird one. Just slow down time. I mean, yeah, that is such a good looking planet. Really do like that one. But yeah, anyways, so let's watch as our second star here approaches the primary star, because that's what's going to cause the most interactions here. So let's just let it roll. Here we are. Okay. So it's the yellow star there. Alrighty. There you go. Let's lock onto the primary star. Okay, so let's see how this changes. So it swoops around, and as you can see, it's caused even more problems. There you go. It's coming back again. Let's slow down time and actually watch it. It's slower motion this time. But look at the state of that. It looks like this desert planet's just been ejected. That was a planet that was really in the heat of it as well. So that's been ejected finally. And there's now going to experience the cold. So that's gone. I don't think that'll be coming back. So let's go ahead and watch. Here it is. It's coming in hot. Now let's see. Look how this is just an insane system. Everything is in turmoil. Oh, hello. Oh, that isn't good. I don't know what's going to happen here. Oh my god. Okay, so it's flying in. Let's see what interactions it could cause. Could really cause some serious issues. Look at that. It is absolutely just destroyed any remains of what was the inner solar system here. I mean, look at the state of that. I mean, that. So we lost another planet. So Tychus here. This was once a planet with possible Earth conditions. It's now been frozen. A world that was boiling hot, now fully frozen up. So that's lost. Lost for good. That's not coming back. Lost. Okay, so we lost that. We also lost Desert Planet. Yeah, that's not coming back either. We'll let time play out a bit. But look at the state of the system now. I mean, God, there's just nothing. No spherical orbits left at all. No oval orbit. Everything is just very eccentric orbits. I mean, even the inner solar system. Look, no one has a consistent orbit. So this system really has been just ruined by this second star's presence and actually being captured. So it's, look at this. I mean, look how far that's been ejected. Look how quick it's going. Speed 7. Whoa. So yeah, nothing near the speed of light, but 7.8 kilometers a second. That is gone. That is just long gone. So bye bye. You're out. Okay. Well, so, oh, Sulfur Gas Dwarf has gone. We also lost Eularis. They're gone. Eularis was one of the hot planets earlier in the system. Okay. Desert Planet's gone as well. Again, a world that was once very hot, but obviously not here anymore. So there you go. Okay, so onto the remaining objects. I mean, let's just turn off the zone, because I don't think it's really required now, because everything's just too hot anyway. So, oh, it's reset to the normal zone anyway, okay. Right. God, look, oh, whoa, what was that? Key Resak, look at the speed of that. That's gone. Whoa. 46 kilometers a second, even faster than the other one. 0.00154, the speed of light, gone. Unfortunately. God, I mean, this is just... Look, I think something else just went. So we lost another chlorine planet there, that's gone. We've lost Muse planet, that's gone as well. My God, this is just insane. The star's coming back for another shot, causing more problems. Look, Cold Deluxe. Remember, this was with the dominant gas giant. So this is still having a big effect. It's not just the other star. This gas giant is also affecting orbits. So, not good. Yeah, Cold Deluxe is definitely causing problems here. And obviously this one's orbit's been upset because of the other star. So now this one is causing a chain reaction here. And now this star, or this planet, is causing interactions as well as the other star. So here we are. There's the star flying in again. Look at the orbit damage that thing causes. It is just insane. Okay. So, we'll go ahead and save, because I think it's time that we need to evolve the star anymore again. So, there we go. Now, remember, because Salby there is a red dwarf at heart, that star's not going to change in the stages of how this primary star's changing. So, we're not actually going to touch that star whatsoever. So, let's go ahead and slow down time. Obviously, we saved, didn't we? Let's just do it again, just in case. There you go. Okay, so, 0.6 AU is the current mass, or size. So, it needs to get bigger than that. So, looks like one of those orbits in Nix's here is actually destined to crash into the star on its next flyby. So, star, 1.1 AU. That is larger than the red giant sun. So, if we get a comparison now. So, if I search red giant, the red giant sun is now smaller than this. So, this is now going into supergiant territory here. So, oh, it's very red, isn't it? That is so cool how the star colour changes as you zoom in and out. That is awesome. So, in Nixus 5, a world that was once a lovely place to be. This had Walter on it at one point, if I remember right. Look at the state of that. It is completely just ruined. Remember, the star luminosity stat as well is also going to have gone up from that. So, we are really... yeah, 1,200 now. So, or 12,000, I should say. Give it a buff there. Let's just watch as this flies back in to the system. But it's on a crash course. The star's got bigger. This one's in the way. What has happened to this? Oh, that's ice. Look at the ice. What is that all about? Well, I shouldn't even have ice on it. There's no water left. Let's just... oh. Well. Get that off here. It shouldn't even have... oh. It doesn't even work. You can't even switch it off. Well, okay. Vegetation? Oh, that counts as vegetation, does it? Are you sure about it? I'm not sure that would really, yeah, 85 degrees of vegetation? Not so sure about that. Anyways, approaching the star for the final time. Assuming its orbit stays on the same course, which it is, by the looks of it. So, it's going to sling around. But the star's a lot bigger now, so as we can see, as it approaches the star for the final time, that temperature is going to skyrocket here. Let's make it look a little more awesome looking. So, there you go. Look at the star. Oh. It's about to get pretty brutal. That star is a menace. Oh my god. Oh, imagine that. And it's gone. It's going in. It's gone. Oh, destroyed. Consumed. Okay, so what's next? Okay. Now, if this star keeps getting bigger, we could see Cold Deluxe, the dominant gas giant, smash into it. Now, that would be a good sight to see. So, and remember, the other star's orbit is also fairly close. If this star can keep going, I mean, if we compared it to our target, which is Antares, or Betelgeuse, which are red supergiants, so if it gets to this size, the red dwarf is going to crash into it, along with Cold Deluxe, probably. So... that could be a crazy sight to see. So let's continue. Now I'm going to keep saving here, because usually once we start getting stars bigger than 1 AU, we do see some problems. So we will keep saving. Okay, so we really are in the end days of this system now. There's not much, it hasn't got much left to give. all the planets are just completely had it at this point. What's that been ejected? We lost another object. We lost one of our gas giants. Okay. Gone. Okay. Right, so what is actually left of the... So there's our lineup. So we still have one of the ice giants in there. Obviously, Cold Deluxe is a nice giant as well. So the only planet left that had any sort of chance of containing or having lifelike conditions is this. But it's at minus 159 degrees. It just hasn't got the orbit to really get where it wants to be. So it's a shame. It's a planet that had the potential but just never got a chance to prove itself and get in that good zone. Again, luminosity is going to go up. We're making it bigger. It's really, really having issues now. And again, size. It's getting bigger. Okay, let's go ahead and save again because you never know what will happen. So 1.59 AU now. So this would consume any... If this was in our own solar system, Earth would definitely probably not be escaping this one. So, okay, let's continue. So it's 20,000 luminosity now, so that's some dangerous stuff. So if we look at the zone, that's the zone currently. Interesting, okay. Cold Deluxe, here we go. So does it actually become a hot Neptune as it approaches it? It looks like it will, yeah. Oh, it definitely will, yes. Obviously right next to the star, isn't it? So, Cold Deluxe. Cool looking planet as always. Our dominant gas giant going up obviously against the dominant star. So, ooh, oh, you can see the temperature. Oh, okay. So it flies by. This was a planet that was once on the edges of the system. This was, I think, at one point, this was probably the second or first furthest planet out. So the fact that it's now the closest planet is pretty wild. Yeah, that is the closest planet. Nothing else gets closer than that. So pretty wild. Yeah, I'm sure Cold Deluxe was on the very edges of this system at one point, at the very beginning when the system first started. This formed at the very far end. So the fact that it's managed to get an orbit going all the way in now is pretty wild stuff. And yeah, now this is 1 AU out. All the original planets, they would have been destroyed at this point anyway, just by the star's sheer size. So pretty crazy stuff there. How's that planet from Chris doing? This one doesn't have an orbit showing up for some reason. It's really weird. That's such a strange planet. I mean, Chris, if you're watching, how's it got no trail, man? What have you done to it? It has a trail colour here, but it's not showing up. So very strange stuff. Oh, that's Cold Deluxe again, causing problems. See, how is this in Nixus doing? So it's still just... It just can't find the temperature it needs to really get what it wants. You know, although it may have the ingredients for life, the conditions are just too changing to really have any chance of a long period of time with good conditions. So it's never going to be, unfortunately, at this point. This star is too erratic now to really have any good conditions going on. So it's a shame, really. Salby, how you doing? So that's just chilling. I mean, that's just a red dwarf, isn't it? So it's not gonna... I mean, a red dwarf lifespan compared to a star like this lifespan. And remember, this was a blue star at one point. So, you know, it's always going to be a lot quicker evolving than a red dwarf. You know, the red dwarf will outlive this star probably hundreds of thousands of times over, because it burns its hydrogen so much slower than a blue giant would with 5 masses of the sun. So, yeah, there's no match for this star's aging period. Oh, Cold Deluxe is gone! Completely gone! The dominant gas giant is out! Oh, ejected! Okay, and now we got the star coming in, the red dwarf. Cold Deluxe, that's a shock. That is a big shock. I was hoping we'd see a crash. So that slings around, causes more orbital chaos. But Cold Deluxe is gone. It's not coming back. It has truly met its match. So the dominant gas giant, probably for the first time ever in one of these, has been ejected. It's not often the dominant gas giant gets kicked out, but in this case it has. Oh dear, oh dear. So it's gone. Oh wow, that was a surprise. Look at these orbits now though, that is just insane. So Cold Deluxe is gone. eliminated from existence. There you go. Salby flying in again, causing more chaos. Again, look, it may have just ejected this green object as well. Look, that's not coming back. That's gone. That's completely gone as well. Okay. There's Salby coming in again. See, it may just... This red dwarf may just clear out our system before the actual main star does. Procon here. So there you go. Flying in again. Causing more chaos. Okay. Oh, it's absolutely insane. This is... I think... Now watching this, I think we're going to know how the system's going to end. The star is obviously going to get bigger. The red dwarf's going to smash into it, and that's going to be the end of this system. And that would, in theory, probably make a black hole or something. You know, that's a kind of an overload of mass. So, I think we just need to sort of obviously manually. It looks like we've got another planet about to smash into this as well. If this object over here comes back, it's going to smash into it. Okay, yeah, that's on a perfect orbital crash course. Oh, look at that orbit though. It is really... Ooh, that's a bit dodgy, isn't it? Okay. Where's our... So there's the red dwarf again, okay. It's coming in. It's coming in hot. Okay. There you go. So it's flying into the zone now, okay. Right, let's see as it flies by close. So, oh yeah. So roughly in this area, it's about to approach now. So as soon as our red supergiant gets to that size, yeah, that's going to smash into it. So, not good. I mean, look at the size difference between these guys. I mean, this is a planet. This is a star that just keeps bouncing around on the outer system, but also now is the closest object to the main star. So, pretty wild stuff. Again, let's go ahead and save while we're here. And now it's time for the grand finale, I think. So again, size, it's getting bigger. Slowly but surely. See, the red dwarf misses out this time, but as time progresses more and more, this star's getting very, very hungry. Luminosity obviously is going to go up more to just ridiculous numbers now. But the star really is... Oh no! Can it not meet its limit? Can it not ever reach the orbit? Oh no! So again, that's why we save, people. So, it looks like the star won't allow us to go much bigger. So if I try going to 2AU, is it going to allow it? Oh, it may actually. Oh, but I don't think this star's going to allow us to get much bigger. If I go to 2.5, 2.58 then, okay, ooh. I think this red dwarf may just be safe here. It may just be able to survive out of that area where this star, when this star eventually goes pop. Oh my god, that is pretty... So, that is... Yeah, I don't think this star is got the potential to get big enough to eventually take that orbit. So unless the red dwarf's orbit changes, we're not going to see any kind of... have a change, unfortunately. We can make the luminosity bigger again. Just insane numbers now. Yeah, that zone is huge. I mean, how far away is that? I mean, how far does that zone actually go for? I mean, let's have a look. So if I was to put a blank, but so 600 AU was that. So roughly this area here. It's annoying it keeps changing. So that it was going past fittiness, wasn't it? Look, fittiness is there. So, whew. Okay, so sulfur gas dwarf. So that object is just out of the zone right now. So this zone is covering roughly 600 plus AU. So yeah, that's a pretty insane number. Yeah. So any object in our own solar system would just be in big trouble now. I mean, look at this. This is an ice giant here. This is now going to warm up extremely high. We've still got the orbit just to hang on in there. Oh man, this is just insane. How's this object doing? That's such a strange object, that is. Okay. Again, this planet here, this was the one with the Earth-like conditions. It's 100 plus degrees now. So again, it just... Oh, this is one of them. This was the largest rocky planet, actually. So it just hasn't been able to find what it wants in this system. How's the Nixus doing? So again, so is it mine? It gets too hot, then too cold. It just hasn't found the nice balance there, unfortunately. Okay. But I think this is the time where we eventually say no more. And this star is about to pop. It can't go much bigger, as we saw. So the only option left is for the Nova. So what we need to do is we've got a place. So Yeah, that's... Oh, yeah, what we do is... So, when this happens... Obviously, if we explode it, it won't create a bright dwarf or a black hole or anything. So, what we have to do is... We got to replace... So, we're going to go ahead and save as well. Because simulating the novas are really, really weird. It's really annoying the way the game makes you do it. Like, when you blow up a star, it should just automatically generate... If you ask me, it should just generate a black hole or a pulsar or a white dwarf or whatever. But with this, you have to do it manually. So... What I have to do is I have to replace this object. So it's got 5 masses of sun. So what I'm going to do here is I'm going to replace it with a 1 mass black hole. Because obviously when a star explodes, a lot of that material is lost. So it makes sense that, yeah, the 1 solar mass black hole takes its place. So you get that. Okay. So black hole has now replaced our star. And then what we have to do is we again have to place the star on top of it. And then explode it immediately for this to sort of work. So, I mean, I guess I'll go with Antares, which is that roughly. So it's a little bigger than our star, but let's just say our star gets really big and then it pops. So then I do that. So as soon as I press play, the star should disappear. Black hole's obviously there, so the orbit should stay. So slow down time. I'm hoping this will work. It's just a bit tricky. You have to do this there you go. Okay, there you go. So the star's gone. Now the black hole is generated immediately. See, we've got our black. What the heck? What is that? What is that? What? Whoa. I don't know why we have a giant gas giant there, but okay. Ignore that. So, all the orbits are still the way they were. And now we have a enormous glow. Look how far this glow goes. I'm zooming out. You can hear me scrolling. I'm still scrolling. That is an enormous explosion. So... Oh, there he is. Okay. Oh, so the gas giant's disappeared. So, there's the nova. Oh, no, the gas giant's still in there. Okay. What is that all about? So, for instance, if I was to place, say, a galaxy on top of this, how is this actually visible? Yeah, it is. Look how bright this explosion is. Oh, man. Okay. That's a little extreme, but okay. But imagine just seeing that explosion. So, we're on one of the furthest objects out here that's still in here. So, X-Shark. Okay, hello. So, pitch dark, and then you look around and you just see that. Look at that. That's a huge explosion. That's insane. So let's actually go to the planet that could never get the life it needed. So, here it is. Okay, so the planet could never get its life. Now we're watching as doom arrives. So, oh, hang on. Play. So there you go. So yeah, the planet that could never ever get the conditions it needed, but now it's about to meet its end. So, star's gone, black hole's all that's left, and as you can see, now it's really getting the temperature it could never really retain. And it is the end of the line. You can see the black hole in there as well. That's really cool. Is that glitched gas giant still? It is still in there. What is that all about? I just delete that damn thing. That shouldn't even be in there. But anyways, so as it approaches the cloud of nova. Oh yeah. Now, is it going to survive? Is it far enough out to survive, or is it going to get just destroyed? It's got 1 mass and radius of Earth, pretty much. So it may be able to hang on. Oh, it is losing material though. It's far enough, maybe, to have survived that. But, I mean, I don't know how many objects are going to survive this. I mean, oh. That looks like a lot of them may have survived, actually. Okay. Because, remember, these are really far away. A lot of these. They're not close. So, anyways, what is this? Get this stupid thing out of here. There we go. Right. Black hole. All that's left in the very, very centre. There it is. So, it's only 2.95 kilometres. So, it's very, very dense. Give it a cool looking... glow to it as well, but obviously that's the center of everything now, so that is all that's left of our once giant star. So we now have a black hole red dwarf binary system, pretty much. So there it is, Salby. So let's now let time advance. Just see how there's a lot of stuff that's scattered. Look, you can see orbits. Some orbits have been lost by the looks of things. Put the labels on as well. So a lot of the orbits have been upset by that, but some of them are still hanging on in there. Okay. Did we get like a multiple nova from this? What is that all about? Oh, no, never mind. So it's a big cloud of material either way. Just let time play out. Oh my gosh, look at the state of that. Okay, so this is all that's left now. So we got the black hole, red dwarf, binary sort of system going on, and there's any remaining planets. Now our primary star is gone, and this black hole only has one massive sun, so it's missing. Obviously, the original star had about 5, didn't it? So obviously, it's got a less its gravitational pull isn't as strong as what it once would have been. So the orbits are even more in turmoil than they were before, with that red dwarf going around causing absolute carnage. Well, look, it's trying to pick up stuff, and then there goes another ejected planet. So eventually, normally we'd finish off these episodes here, but because we have another star, eventually this red dwarf would fade out as well. So there we are. But remember, it's all speculative what happens to a red dwarf, because no red dwarf in existence has ever died before, because they live for so long. So there we go. But let's just get rid of the ejected bunch of objects, because they are gone. So again, all of these are just completely gone. They're not coming back. So the only objects really remaining are just the... I mean, look, we pretty much lost all of the objects from that. All being ejected by this red dwarf. So this is really the only remaining objects left, is all of these. And it's just a absolutely insane orbital mess. And I don't think many of these are going to last much longer. I mean, you can look at this. What is that all about? Oh my god. Or maybe they will hang on. I mean, look at it. Oh. See, that interstellar traveller star really changed this system forever when it flew in. Look at this. Oh my gosh. Look at the orbits just bouncing around each other. Look, there's just no consistency at all. Okay, we've lost another object there. That object's been lost as well. So it really is these all that's left. Oh my gosh. Look at that. In an ideal world, imagine if the sulfur gas dwarf got picked up by the star and it just orbited the star forever. That would be pretty cool. There you go. But again, the star just keeps causing... Oh my god. Ah. This orbit's just trying to hang on in there. Oh, there's another ejected one. That's gone. X-Chac finally gone as well. Again, that was a green trail, so that did have conditions at one point. What's this mole object doing? I don't think that's ever coming back either. Okay, so it really is just... Oh, and that's gone as well. So, all that's left, that has cleaned out everything, and it's just a double binary system of black hole, red dwarf, all that's left. Literally, that is all that's left. It's bigger than that as well. So, at this point, a very, very long period of time happens until this star eventually, because it's a red dwarf, it won't ever become like a red... Well, we don't think it... Again, no red dwarf has ever died before, so we don't really know what would happen to a red dwarf as it ages, but eventually it will just fizzle out. So, really, it will just sort of go down. I mean, I don't know. I think there's a theory that it become what's called a blue dwarf, where it just... See, I don't really know what to do here. Does it increase in temperature? I mean, I guess it would increase in temperature eventually, but it doesn't really allow us to go any further. So, obviously, its luminosity would go up as well. But eventually, it would just slowly lose that mass. The mass would obviously drop as it just slowly burns out after a long period of time, but then it would just slowly crunch down until maybe it becomes a gas giant again. I don't know. But it would eventually just fade out into nothingness. And it would just be... It'd probably just become a black dwarf. So if I just made it back into a star again. So it probably would eventually just sort of lose its temperature and just go all the way down to 0, really. So it would just sort of... And this is... We're talking probably billions of years. But eventually a red dwarf would probably just sort of slowly but surely just sort of dim down until there's just nothing left. And then pitch back. Nothing left. I'm assuming anyway, but we don't know. We don't know how a red dwarf would end. Because we've never seen it. And we don't know, because no red dwarf has died. So, I mean, if anyone has any other ideas what we would do, let us know in the comments as well. But, yeah, a red dwarf, it wouldn't it wouldn't explode, go into a planetary nebula, nova, anything like that. It would simply just sort of fizzle out, and there you go. That's all that's left. So, then it would just lose a bit of mass, and maybe it will just become a blacked out star. So, maybe that. There you go. And that'd all be its left. Just lost all of its... No more fusion process. Just lost all of its material. So that's all you'd get left. Is something like that. I mean, since we can't simulate the black dwarf. I mean, there you go. And then these guys would be in a binary forever. Until they eventually just dissolve anyway. So, I mean, we can just explode it. Boom. And then that goes boom as well. They eventually just dissolve via the Hawking radiation theory. And there you go. So no more system. So this is after a ridiculous amount of time. But look how much time we ran this simulation for 6.22 million years of game simulated time. That's pretty cool. But yeah, there we are, guys. That does it for the end of this system. So I really hope you've enjoyed this four-part series of evolving another custom solar system from birth to death. So that was version 7. So we've done 7 versions of evolving a system now. That is crazy. But I know you guys are still enjoying it, so there'll be more to come. So stay tuned for those. And yeah, guys, let's see if we can go for 60 likes on today's video, and also subscribe for more. Helps on the journey to 30,000 subscribers now. Really appreciate all the support and feedback that you guys give. And yeah, with that all said and done, guys, make sure you have a great day, stay safe out there, and I will see you in the next video. Goodbye.